Hello students, in this session we will practice how to identify the electric intensity direction. In previous class we understood how to give the direction of electric intensity. Here we are going to practice only giving the or finding the electric intensity direction. Here in all these problems we are going to find the direction of electric intensity at O, the common point every problem. We have to find the electric intensity point at O in the system of charges. System of charges either is one or more than one at the considered point. Is the first one. Here we have to, the first stage is find the point. This is the point. O is this point. We have to find the electric intensity, and the charge surrounding it is going to be, this is the only one charge, the source charge. The line joining the two charges, the first, and we have to assume that plus 1C had to consider. If this charge is going to be present, it is no matter, it is not going to be affect in changing the direction of electric field at this point due to this charge. We have to consider always a positive 1 coulomb of charge. This is called unit positive charge, a unit test charge. Now the coulombic force experienced by plus 1C due to this is going to be repulsive, hence it is along the line joining and it is away from it. This is the direction, this is the coulombic force. In this case, we are last class we are told very clearly we have to give the proper arbitrary notation to denote force or electric intensity. Here the considered point is O, but there is no point or any notation at the point of this charge. Let it be considered as any arbitrary charge. You can take this is going to be point A. If you take this is point A, then the force experienced by the charge plus 1C at O is going to be O by O, A. Similarly, this is the electric intensity direction. I represent it by E, and the notation of this one is going to be E electric intensity at O due to the charge, source charge at A. This is what you have to decide. You can take any arbitrary values notation. Then electric intensity at O, here the line joining and plus 1C. Now this plus 1C due to this charge is this is negative and this is positive, and is a coulombic force is going to be attractive, hence it is going to be acting towards this. The electric intensity is also same. This is O due to A. Similarly, electric intensity O here, the line joining here, and this is a positive plus 1C. This is a positive and this is plus, this is going to be along this line, and electric intensity, I am writing direct electric intensity. This arrow mark is representing the coulombic force direction, that itself is electric intensity, and the notation is at O, but the two charges I represent, this is going to be A. This is electric intensity due to AO at O due to A. This also positive at the same line. This plus 1C due to this also repulse, and it is going to be acting, force is acting in this direction. This is the electric intensity at the same point due to this charge. Let it be at the orbital is going to be B, is going to be in this direction. Therefore this is the same point O, but due to B is this is the direction. Similarly, at this point there is no name is there, therefore first to give the name A, B. This plus 1C, this is plus 1C is going to be attractive, This is electric intensity. The force direction, I am not writing the F now. Now onwards I am not going to represent F. It's understood. This is only thing is notation at O due to A. Similarly, at O due to minus Q, which is at point B, the line joining, and plus 1 is attract towards this one, and this is going to be electric intensity at O due to B. You practice more number, because these are very important in solving the problems, understanding the derivations, understanding the many concepts. And the fifth problem at O, line joining this is plus 1C, here negative, and this is positive. This is a plus 1 attract towards this one, electric intensity O due to charge 1 and 2, on this line joining these two, and this is a positive, this is a positive, and here it is going to be repulse. This is going to be electric intensity O due to the charge at 2. And now electric intensity O due to this is going to be plus 1C. Now I am not going to represent plus 1C also, no need to write. Now onwards I am writing directly positive and plus 1C here, repulsive this direction, electric intensity at 2 due to charge 1, and due to this is a line joining. It should be represented, line should be drawn, it should not be simply arrow mark. Then this also positive, repulsive, this is going to be at O, electric intensity O due to 2, and here due to this line joining, this is minus, but here don't confuse that this is another charge which is present here, minus Q. This charge is not affecting anything to change the direction of electric intensity at point 2. Here always we have to consider is a plus 1C. Is a plus 1C, this is going to be, this is attract here, this E at O due to A, this is a point A, then this is going to be attractive, and this is going to be, see here, this is a minus, this is also plus, this is a plus, then it is going to be attract, it is going to be attractive, is electric intensity at O due to charge B at B. Similarly O, and this is Q, this is a minus, this is positive, this is going to be positive, and this is going to be plus 1C, this minus nowhere concern, plus 1C plus this both are going to be repulsive, electric intensity at O due to A. This is minus, this is plus. Here it is a plus 1C, this again this is going to be between these two charges, attract, plus 1C minus attract, electric intensity at O due to the charge at P is minus Q is going to be in this direction. This is the thing you have to practice, so that once you reach the level that you can, by seeing that, you can start identifying the electric intensity direction. We will solve another one or two. The point is going to be here. Now the charges are going to be this, and these are the charges surrounding it. They find the direction of electric intensity at O in the system of charges. Here are the three system, but which is the point dashed here, and this charge will not affect here because it will not experience any force on itself. Or if I am going to keep another charge at plus 1C here, there is a force experienced by the plus 1C is only by this and this, because the plus 1C is also in the same charge. There is no question of force experienced by the charge at Q by itself. Now the O due to this and this, first by nearest one, Y, the line joining, plus 1C, this is also positive, is going to be repulsive along the line joining, and away from it, electric intensity at O due to charge at Y. And this is a minus, and this is also line joining along the this, and this is a minus sign, this is a plus, they are going to be attractive. It is going to be electric intensity at O due to charge at X. See, we discussed in the previous class representing a notation of electric intensity is a very important thing to identify the respective source charge we told. Why? Because here by writing these two arrow mark, I can say that EO is the electric intensity at O, due to which charge to the source charge is Y, and we can represent EOX. This one we can say that is electric intensity at O by the charge, source charge X. That's why notation is electric intensity is a very important to understand the derivation also. Then O here, this due to this plus 1C is going to be here. This is a Y at Y. The plus Q repulsive. This is the electric intensity at O due to charge Y. This is also positive. This is also electric intensity at O due to the charge at X is plus. This is a plus, repulsive. Again, this is going to be electric intensity at O due to X. Similarly, now the O is going to be here. This charge not considered. To identify the direction, first nearest one at point 1, it is going to be minus Q. This is going to be plus 1C is going to be here. Then it is going to be attracting. This is electric intensity at O due to the charge at 1. And this is a minus, and this is a similarly with this. This is from here to here. Then the line joining is this. Then the electric intensity at O. There's a plus 1C. The force experienced by this is going to be attractive. This is also electric intensity at O due to the point charge at 2. Similarly, O here. This is going to be nearest one. This plus 1C is here. This is going to be attracted. Electric intensity at O due to charge at P. This is also minus. Plus 1C is here. This is also attracted. This is the electric intensity at O due to the E prime. Similarly, we will solve another 1 or 2. And the next one is these are the arrangement of the charges, system of charges. We frequently come across the problems. You have to practice. They are simple. The only thing is along the line we have studied. Now it is going to be organized in a regular shape, triangular form, square, rectangle, hexagon, like this. We'll solve the another 1 or 2 sheets so that the student can understand and practice the perfect in their mind. By seeing them only, at any point they can find out what is the direction of electric intensity at a point to give with respect to a source charge at point O. Now there are, with respect to this, there are 3 charges surrounding 1, 2, 3. They will affect the electric force present at the plus 1C coulomb of charge. If I keep here, the 3 forces are acting at here. And now first one here, this is going to be positive and this is going to be attractive. Source charge is at minus, means plus is attracted. Electric intensity at O due to the charge 1. 1 means this is I represented as Q1, I make it as 1. This is a 2 minus, this is this attracted towards this. Therefore this is going to be electric intensity at O due to the charge at 2. This is positive. This is also plus. Positive means this is a repulsive. The acting away from it. This is a repulsive. Electric intensity at O due to the charge at 3. This is the thing. Then here, in this case, at O. Yes. Now Q2 will not going to affect the electric intensity direction. It will not going to be involved in the producing the electric field at the same point. Only Q1 and Q2 contribute the electric field at the point O. The Q1, if I keep the plus 1C here, due to the Q1, it is going to be attract here. This is going to be EO due to 1. Similarly, the positive and positive repulsive, it is going to be EO due to 3. And the O and here another charge is kept here, we should ignore to find the electric intensity. Now minus, this is a plus 1C. If I'm going to keep, this is a EO1, positive, repulsive, it is moving this, EO2, and don't write within this arrow mark. This is gives a lot of confusion. Make this outside. When is the repulsive? To Q3, this is a Q3 is going to be positive, and this is a plus 1C. It is a line joining away from it, QO due to 3. 4, positive, this is also positive, this is again EO due to 4. Then another charge Q, the O is not given here, let it be O is going to be here. If the O is going to be here, then the Q4 will not produce and contribute any electric field at the same point, Q2, Q1 and Q4. Then Q1 is a positive. If I get the plus 1C, it is going to be a repulsive, and it is going to be in this direction. Then Q1 is going to be represented by UO. This is, don't write this is a 4, because this is going to represent O, UO1 due to charge 1, and this is 2 is attractive. This is going to be EO2. This is also attractive, EO3. And lastly, we will solve another one. This is a hexagon, regular hexagon. 1, Q1, Q2, Q3, Q4 is arbitrarily I chosen for practicing the direction. At O1, you had to find that O means plus 1C. Plus 1C, this is a positive, this is going to be repulsive, EO due to 1. Then 2, EO, this is also repulsive, this is EO due to 2. Then Q3 is a attractive, plus 1C here, this is attractive, EO3. Then 4, this is a positive, and this is positive, repulsive, plus 1C goes this direction, repulse this direction, EO4. 5, this is attracting this direction, EO5. 6 is also attract, EO6. Similarly, this is going to be O at the center, 1 at P. If I am going to give plus 1C at the center, then at the considered point O is center, hence I'll keep the plus 1C. Then what direction it, this plus 1C experiences a Coulombic force direction due to the positive charge. This is going to be repulsive, EO1. Then due to 2, repulsive, positive and positive, but the line along the line joining should not give anyway. You have to give here EO2. Then 3, this is a positive, repulsive, again in this direction, EO3. Then 4 is a attractive, plus 1C, this is going to be attractive, EO4. Electrostatic force direction at O due to charge minus Q4 is EO4, which is acting towards this direction. Then 5, this is also same, attractive, this is EO5. Then it is going to be 6, this also minus, this is going to be EO6, it's going to be attractive, it's going to be this. Then finally, this is the one where in the coordinate system the charges are distributed in this way. Then electric intensity at O due to all the three will contribute. Then if I assume that the plus 1C I kept here, this is going to be the line joining these is going to be this. This is a O, and due to 1 is going to be attractive, plus 1 say attract towards this repulsive or the attractive force. The electric intensity at O due to charge at 1 Q1 I represent this is, and due to Q3 is going to be repulsive, it is acting along this direction, and this is a EO3 repulsive. This also repulsive because the positive along the line joining, and it is in this direction. This is EO, this is Q1, this is Q2, EO2. Students, if you practice, then you can, by seeing the point and the source charge, you can identify the direction without drawing also. Practice this. This is a very important thing. In next session, we will start the derivation and the developing the whole chapters and application of E, how it is going to be understood in a different charge bodies and surrounding it by understanding its magnitude and identifying the direction. Thank you.